Ladies and gentlemen, thank you for coming and behold UW 2023 Design Build Fly Unveiling. All right, we'll do take two on that. Take three. Third time's always. High-speed pass incoming. 100, 120, 130, 140. There you go. Now we look good in the light. Okay, so good afternoon, everyone. My name is Pranav Bhagwatula, and welcome to the Design Build Fly 2023 Unveiling. This is a gigantic crowd. I'm really happy all of you could be here. I didn't know so many people were invested in one RC plane designed by a university. But I am the project manager of the club. That's me from 1 year ago, and you can see the difference on the right pic after a lot of calories later. And I've been the project manager for 2 years now, and I'm a senior in the UW Aeronautics and Astronautics department here. I've been doing DBF for basically my entire time here at UW, and it's been a fabulous experience that I want to take you through. And my co-MC for the day is right here.
All right, hello everyone. I do want to echo the welcome. We're really excited that everyone has turned out for this event. It's been a really exciting year, so welcome. My name is Kaylee Stagnone. I am the Chief Engineer for Design Build Fly. I've been a part of the club again for 4 years, and this is my second year as Chief Engineer. I'm also a senior in the Aeronautics and Astronautics department here at UW, and just very excited to showcase everything that we're doing here this year. All right, so first of all, we are going to have a keynote speaker. So to anyone who's on Design Build Fly, Brian Kelly does not need an introduction, but for those of you who are here with us today, we want to give you a little intro to who he is. So Brian Kelly is the president of Marymore RC Field, and he has been the president for 3 years now. He's also been helping out our team for the past 3 years with both flight tests as well as design and manufacturing recommendations for our team. We really would not be here without the support that he's given us and been able to help us with the flight tests at Marymore. We do fly our planes at Marymore Field, so they also sponsor our team as well. So it's been a really big help over the past 3 years, and they've also seen us grow quite a bit. To give you a little bit of a background of who Brian Kelly is and what his experience is, he graduated from the University of Southern California with his bachelor's in aerospace engineering. Then he got his master's from Stanford in aeronautics and astronautics. He also worked for Boeing for 32 years and has extensive experience with RC planes. So without further ado, I do want to welcome Brian Kelly to the stage to be our keynote speaker.
Well, good afternoon, everybody. I'm really pleased and proud to be here, and I'm really proud of this team and the teams from the 2 years before. And thank you for the kind introduction. Ever since I was, like as high as that microphone over there, I thought they were setting it up for kindergartners or something. I've just been fascinated with how stuff works. That probably rings true for any of you who are engineers. But in addition to that, I've just always had this gut idea that I'm not only fascinated with how things work, but what is sort of the human visceral reaction to that when you're making it. So it's not surprising that I sort of gravitated towards airplanes and flying, and maybe especially RC airplanes. That's the hobby that I seem to keep coming back to. Just a little bit about our club over in Redmond. We're big. We have 330 members. Thankfully, they don't all show up at the field at once. But all summer long, we have barbecues and contests and so on. And all year long, we have monthly meetings. If you're ever interested, come check us out. We're also proud that we do educational outreach. We do our best. We have a all summer long training program that's free for anyone who wants to be a member, which is only $60. So we'll teach you how to fly. You don't need me to bring it. We've got our own fleet. A couple of years ago, we pulled off an all-day event called STEM Day for a whole bunch of middle schoolers. That was a lot of fun. But we're especially proud and pleased that the UW team came and asked us if they could use our field and asked us for a little help and support. And so we've just built this relationship over the last 3 years. Now, the volunteers, in addition to myself, there are 3 or 4 others, help with design reviews and mentoring, and helping check over the plane before it flies to catch little things here and there and pass on advice. We have industry experience. We have some academic experience. A lot of us are engineers, and we've got a lot of practical RC experience. What the students bring to the table is they've got the theory fresh. Mine sort of expired a while back, in spite of those degrees. So we complement each other very well. Now we're just really impressed, though, with the maturity, the leadership, and communication skills that all these students show, and we're impressed with their technical chops too. They're a good bunch, if you don't know that already. So we've witnessed 3 cycles now. We've seen the Dragonfly 2 years ago, the Albatross last year that placed quite well, and this year we're unveiling the Sailfin. What we've observed is the sheer size of the team, which I guess you can do in a place as big as UW. There's a lot of diversity in age and backgrounds in engineering disciplines, maybe even not even necessarily engineering disciplines. The team seems open and welcoming to anybody who wants to pitch in. I see atypically good listening skills. It seems like they're all talking to each other at once, but then I find out later that they really are actually listening to each other at the same time. It's surprising. The interaction between the individuals and between the sub-teams is very, very much like it would be on a small aerospace engineering company. We've got structures, aero, propulsion, and so on, and everybody's got their own axe to grind, their own part of the machine that they've got to optimize. And they've got to sort all of this out. Now what happens is the people at AIAA, the American Institute of Aeronautics and Astronautics, they know this. And they've built this fantastic program. And it's so much more, I just want to tell you, it's so much more than just sort of putting theory into practice. Design, build, fly is almost everything that your academic curriculum is not. They're almost completely complementary. You'd be taking classes one at a time in thermodynamics, structures, et cetera. But when you go work on DBF, you've got to work on everything. And nobody wins. You got to sort it all out. So AIAA develops these missions, these what one of our other mentors called diabolical missions that force the teams to butt up against each other. They force you to use optimization strategies. They force you to bump into surprising real world limitations. They'll force you to struggle and fail and recover. To mitigate that, I've watched the team learn how to set their requirements early and involve lots of people, including their consultants early on and at every stage of the process. In addition to that, we see growth in the students every year, year upon year. We just watch them grow. Previous students become mentors. Lessons learned get carried forward to the next year's team. We see teamwork, leadership, friendships, and really good communication skills, both at a daily level and also, as you see, doing things like introductions. Here's the key point. You guys that are doing this, you know, people that aren't doing this, you can't get this experience any other way. I don't think you can get this experience in a well-run internship program at Boeing, where I came from. It just won't be as interactive, it won't be as intense, and it'll be too brief. So this is a really unique opportunity. Now, think hard. What do we really want? We want the Huskies to win, right? So here's your biggest challenge. Your biggest challenge is that each year the team changes. You don't get to carry the continuity automatically. So the lessons learned and the support that the team gets at home here at the U are crucial. Professors and instructors, how can you support the program? You can learn about the missions that AIAA DBF comes up with. You can learn how those missions might relate to your coursework. You can look at how those missions, how your coursework might relate to the other coursework going on across the hall and see if there's something cross-disciplinary that you can do that relates to the missions. You can help connect the DBF teams and the team leaders with industry and academia that may have relevant tools and methods. You're not restricted to getting all your tools and methods from UW. You should be looking everywhere. You can show the students how far and wide they can network if they're not already way ahead of you. You can show them optimization methods and tools that may not have been covered in any coursework or things that grad students are doing. It's clear from what I hear from the DBF leaders that the teams that do really well nationally and internationally have a lot of support of this kind of company. Second, parents, what can you do to help Huskies win? Number one is do not be concerned that so much of your students' time might be going to this frivolous, idiotic toy airplane fantasy. It is, like I said, it's highly valuable experience. Their grades might suffer just a little bit. But this kind of rounding out from what I've seen gives them about a 3 to 5 year leg up in terms of maturity and experience compared to somebody who does not take advantage of these kinds of opportunities in school. And this comes out in the interview process. So your son or daughter may get hired or the other one won't. Next, students and DBF team members, what can you do to win? Well, before I get right into that, If you're not in this extracurricular activity, get one. They're all good for you. If you are in this one or one like it, get down to the lab, get your hands dirty, start to develop an intuitive feel, a tactile feel for your engineering. Find out what works and doesn't. Get your hands dirty, but do wear your gloves when you're playing with the epoxy, and wear the mask when you're playing with that carbon stuff. Learn how to be a team member. That's something that doesn't come automatically. Learn how to be a team leader, even less automatic to most people. Encourage your friends to join. DBF team leaders. Number one, document the lessons learned as you go along, and then summarize them at the end. Don't put them in your AIAA report, because this way you can write down all the mistakes. Let the missions drive the technology that you use. Stay focused on the missions. Use off-the-shelf proven RC technology whenever you can, because that can.
What?
Just remember, everything on the plane has a purpose. I think one of you said that. Above all, make it fun. And I see you doing that. You're doing it really well. You leaders are the leaders of a sort of a fraternity/sorority. And what you're doing is you're developing lifelong friendships and professional relationships. Don't underestimate that. This becomes so valuable. And for everyone, it's everybody's job to create great memories that are going to last a lifetime. Now, I want to congratulate this year's graduating seniors from the DBF program. Stick your hands up. Can all the graduating seniors stand up just real quick? You all know who they are? As I've watched you grow and from what I've seen, you are an impressive bunch. Each of you can pursue pretty much anything you choose. Choose wisely. It's been my privilege to help out and a real joy to get to know you. I wish you the very best of luck in Arizona. I really wish I could come down and see it. If there's a way to see something streamed or get any kind of news, I'll be listening. And especially, I look forward to seeing most of you again and finding out what the diabolical challenge is for next year. Thanks very much.
All right, thank you so much, Brian. That was an amazing speech. That inspired me sitting in the front row. So thank you for those kind words. And yeah, DBF is a little bit of a fraternity. We are Delta Beta Phi. And so a lot of you who are members here already know what DBF is. Parents might know a little bit, but there's a lot of people who kind of know that we build planes, but what exactly do we really do? And I'm going to guide you through that. So Design Build Fly is an intercollegiate AIAA competition. With less jargon, that's the American Institute of Aeronautics and Astronautics. That's the foremost body of aerospace in the country, and they designed this amazing opportunity for students like us to build a full-size, large-scale RC aircraft to compete against teams from around the world. It's also an opportunity for engineering students to get some real-world experiences, Brian alluded to. And it's really important for us to get this in today's ever-growing engineering industry. So we become one of those avenues of growth for a lot of different students. And lastly, it's something that keeps you engaged throughout the year. Design Build Fly runs from fall quarter to winter and then to spring. And we divide that design, build, and fly part pretty evenly across the board. Come fall quarter, we get the rules. We get a 1 month disadvantage because we're on the quarter system, because they release when we're still on break, ruining everyone's break. And corn hunt. But that's when we start designing the plane. And towards the end of fall is when we freeze our design and move forward into manufacturing our designs come winter quarter. Around in winter quarter, we produce about 3 aircraft usually in that very short span of time. We make one out of foam and tape materials that can be built in like 3 to 5 days. Not really. I know I write that as the timeline, but it really doesn't happen that way. And that plane, it validates our aerodynamic characteristics. Then after that, we test our manufacturing ability with what we usually refer to as V1. V1 is where we put everything on the board. It's our first attempt at making the plane that we want to take to competition. And then we learn all the mistakes from that and we make V2. Keep in mind, all of this is happening in 10 weeks, so nobody's sleeping, grades are down, it's a fun time. But what's the best part of this is then we test those and then we iterate on that. When we iterate on these planes, we learn what their weaknesses are, and then we make the final baseline for competition, what we refer to as V2. So this is kind of insight, and I'm going to take you through the design, build, and fly stages with a couple of pictures here. This is something we're really proud of, and it just might look like a random CAD drawing to you. But on the left, this year, one of the challenges, as Kaylee will talk to you about in the missions, is being able to rapidly assemble and have manufacturing ergonomics. What we've designed is essentially an ability to connect 2 parts of the plane within 2 seconds, and you'll see that later today as well. We use CAD softwares all alike that industry utilizes, such as SolidWorks, and what we also do is employ industry standard methods of figuring out how things shouldn't break, or FEA as some people might call it. And we run that on a lot of our parts. We use a lot of software to simulate and make sure that our build plane will work as intended. But a lot of that can be outside software too. Most of our drawings start on a whiteboard somewhere in Guggenheim. If you're a student in AA, you've probably seen us leave some planes behind. But that's kind of what that looks like. And this is my most favorite part of DBF. It's that a drawing on the board can turn into a fully built aircraft that goes and flies ridiculously fast. So that's a bit of like what our meetings look like. We're just standing around, bickering at each other as to what is the best option for our plane. Then come winter quarter, as I talked about, we do the build part of things. And that's all of us pretending that we're enjoying that build right there because it's actually 9:30 p.m. But we work with a lot of novel materials that have been used on the 787, for example, like pre-preg carbon fiber. And we lay those up, cured in an autoclave. If that sounds familiar to you, it's basically like baking a pizza, except the pizza is the plane. And that's what it looks like when we're in the shop laying up. Well, they're not smiling anymore, as you can see. Things don't go so well always, but we learn a lot during the build phase. That's an example of us bagging our fuselage for it to cure. We use a lot of composite manufacturing in-house. We make a lot of our parts. We almost buy nothing but electronics. So it's quite the challenge, and we've learned a lot about manufacturing along the way with that. And this is the best part, which is fly. That right there is the prototype of what you're going to see later assembled today. And that's V1, as we would call it. It took flight around late January and mid-Feb, and we got some amazing data out of it. And every time we go to the field, we have a lot of fun when it's done. So field days can be extremely long and time-consuming, but when you see the plane go into the sky and you get that data and you see it like bank like a fighter jet, it looks amazing. All right, so that's design, build, fly. And now let's talk about this team in particular, because all teams across the universities are called design, build, fly, but we're called design, build, fly at the University of Washington. So that's the team, pretty big one. And I don't think we've ever gotten everyone in the picture ever, but that's the first time. We're a 70-member team. We have had record recruitment practically every year that I've been here. And there's always people who want to join the team. But unfortunately, there's only so much work that we can have. So we make decisions based off of initiative and people who are driven and want to be on the team. Experience is not something that we look for at DBF. What we look for is someone who has the fire in their belly to make a plane and learn new things. And that's what drives our motto, which is educate and compete. While we build a plane that's going to go out there and destroy the competition, we also want to make sure that we're educating people along the way. And we have our previous members who trained us to think that way, to thank for. Our club is also majority freshmen and sophomores, unlike most teams across the country. Most teams across the country treat it as a senior design project and are usually around maybe 40-person teams or even smaller sometimes. But keeping our motto in mind, we always make sure that we get in more freshmen and sophomores so that success journey continues even after we're gone. And it's a really important thing to us that we get people with that initiative and want to learn. And we notice that freshmen are usually more enthusiastic than a jaded senior. We also have 5 sub-teams. So across the sub-teams, you have aerodynamics, you have structures, you have payloads, materials, and manufacturing. These 5 sub-teams basically control all the different verticals of our little aerospace startup that we have here. They work together, they have different leads, and they essentially produce designs that are relevant to their sub-team. For example, the aerodynamics designs wings, outer surfaces. Structures make sure that those surfaces can withstand all the flight loads. Materials make sure that we get high strength and low weight. And lastly, payloads make sure, or penultimate one is payloads, and they make sure that we can fit all our payloads and design them to spec. And manufacturing makes sure that all these pipe dreams can actually turn into a reality. So our progression, we have really come out of the ashes, and I'm gonna have Kaylee here talk about all of this.
Alrighty. So yeah, pictured on the screen here, we actually have the past 4 years, how we've done in competition. So as you can see, we started off 4 years ago, so the year before my freshman year, where the team placed 93rd in competition. There are only 100 teams that compete in competition. So as you can see, it's not a great position to be in. But we, the leadership team that year really took that to heart and wanted to really push the team to improve. We actually have a couple of those members here today as well, so we're excited about that. But they helped to build up this team to where it is today. So then starting after that, so my freshman year and a lot of the others, the current seniors' freshman years as well, we placed 46th in competition. Now this was just based off of our report score because this year competition did not take place due to COVID. And then once again that happened again our sophomore year when we placed 43rd. This was a little bit different. It was based off a report score and a video that we submitted. So that was how we placed during my sophomore year. And then last year we placed 9th in competition, which is actually the best that the University of Washington has ever done in a design build flight competition. Thank you. Yeah, we were really excited, and that kind of I think lit a fire under a lot of people here because we have really been pushing to do even better this year. So that's a picture of the Albatross, which is the placed 9th in competition last year on the right. So it's a really great plane, and it was really fun building that. So, but going into that, we want to talk a little bit about our goals for this year that we've been kind of driving our team behind. So as we just mentioned, we got 9th last year, and so our goal this entire year has been to win competition. And we're really been designing every part, building every part with that intent that we want to make a plane that is going to be able to win competition. So it's been really, really exciting to see the work everyone is putting in to be able to make this goal happen. And we're really excited to showcase what we've been working on, so to everyone here as well. After that, as we mentioned, our motto is educate and compete. So we really want to make sure that we are educating the next generation of engineers because they're all going off to work in industry. And we think that this club experience is really valuable to us going into that. And as Brian has talked about as well, it really makes a huge difference in talking with interviews and going into industry and working. I know that from experience for myself is having this experience has been really essential into all the jobs that I've worked in industry. So, and finally up there, our goal is to have fun. Sometimes they have to pull late nights and whatnot. It may be a little bit less fun in those moments, but looking back, it's always a great time to have been working with our team and to get this experience and making friends. And it's just a really special experience to be able to have, and I'm really thankful for everyone who has been a part of this journey as well over the past 4 years for me. So yeah, that's a little bit about our goals for this year and what we've been driving our team behind. So now we want to tell you a little bit about what the competition is for this specific year. So as we mentioned, it changes every single year. So the rules are never the same, but we want to talk a little bit about what we've been designing the plane around this year. So first of all, we have mission 1. So there are a total of 4 missions that we'll go through today. Mission 1 is the same every year. It basically is a proof of flight for our aircraft. So we have to fly 3 laps within a 5-minute time frame. And those 3 laps, doesn't matter we don't get any more points for flying them faster. We just have to complete this mission. And when we complete this mission, we get 1 point. So, and as you can see pictured on the screen as well, we have the flight schedule, or the lap course that we have to complete. So every 3 laps, we have to start, we have to take off, and then on the returning lap, we have to fly a 360-degree turn to kind of show we can turn in both directions, and then continue on the course. So we have the dimensions listed there as well. The overall flight length is around 1,000 feet in each direction. So, and for this year, the takeoff distance is 60 feet. It does change from year to year. So last year we had 25 feet, but this year we're taking off within 60 feet. For Mission 2, this year it's our surveillance flight. Mission 2 is generally some sort of payload flight. So we have to carry a different type of payload that generally when we have more payload, we get more points for the mission. So for this year, it is an electronics package. That is in quotes on the screen because it's not actually containing any electronics. It's kind of like a dummy weight. But the electronics package for this year has to be minimum dimensions of 3 inches by 3 inches by 6 inches. And we get to decide how much weight we want to put into it, but the minimum weight is 30% of our aircraft weight. So for this year, our aircraft weighs about 10 pounds, so we have to have at least 3.3 pounds inside the aircraft. We are doing a little bit more than that, as we can talk about a little bit later. And the goal for this flight is kind of it's an endurance mission. So we have a 10-minute flight window, and we want to fly as many of those laps, the lap cycle that was shown on the previous slide, within the 10-minute time frame as possible. And the scores for Mission 2, Mission 3, and the ground mission are all normalized on the other team's scores. So basically, the team that flies this mission the best, which means they have the most number of laps flown times payload weight, they have the highest value of that, then they get the score of 2 for this mission, and then any other team is normalized based off that highest score. For Mission 3, there's generally some sort of complicated like pilot maneuvers or whatnot, or deployment that has to take place during this flight. So for this year, we have what's called a jamming antenna that we have to mount onto our plane. So the jamming antenna is really just a half-inch PVC pipe. And we get to decide how long this is again, and the longer we can make it, the more points we get. But it's also normalized based off how fast we can fly. Now, the previous mission, Mission 2, was an endurance mission, so we had 10-minute flight time. But this mission, we have to fly 3 laps, we have to fly them as fast as possible. So it's more of a speed mission, we have to try and go as fast as possible. And so the antenna that we have to mount has to go vertically off the tip of our wing, and it'll change there's no specific wing tip that has to go on, it's gonna change depending on which direction we are flying into, where the headwind is at competition. So yeah, for Mission 3, we have to, it's again normalized off the other team's scores, and so it's 2 points plus the normalized of the length of the antenna over the time that we fly. So we're trying to fly 3 missions as fast as possible. So after the Mission 3, we also have a ground mission that we have to do. And generally, this is some sort of loading payload or whatnot. And this year, it's actually a structural margin demonstration. Now, what that means is we are going to be mounting our aircraft, as you can see on the screen there, between 2 different test stands. And those test stands, we do have them here with us today that we can show you after the presentation. But those test stands are designed by the team, and we have to be able to mount our plane onto it. And then directly in the center of the between those 2 test fixtures, we are going to be loading weight onto it. And we get to load as much weight as we want to. This means if we think our wings are going to fail at 100 pounds, we maybe load a little bit less than 100 pounds onto our wing. So we can decide how much we want to add on there. It's just based off of how much our plane can take. And the more weight we add is going to give us a higher score. But what's important for this mission as well is our strength to weight is important, because the score is normalized based off of how heavy our gross aircraft weight is. So how much our plane weighs overall. So it's important to have that strength to weight component for this mission as well, because our ground mission score is dependent on that. All right, so we have the main missions, but we also have some interesting requirements that we have to meet as well. So first of all, for space and size. So this year, the aircraft has to fit inside of an airline compliant shipping container. But it doesn't have to fit like all assembled. We can disassemble it and put all the parts into this container, and then we'll have to assemble it at a later time, which we'll talk about in the next slide. But essentially, an airline-compliant shipping container means it has to weigh less than 50 pounds, so the box plus all the plane components inside. And additionally, it has the length plus width plus height of the box can't be greater than 62 inches. So what we've done is we went ahead and maximized that length as much as possible in order to fit the most components and make our plane the most optimal based on the box size. So we have that restriction for space and for size. Additionally, we have some requirements for manufacturing consistency as well as assembly time. So for manufacturing consistency, inside of that box that was shown on the previous screen, we have to put in an extra set of wings. So this means we have to have a left wing and a right wing. We have to have two of those inside of our box. And so these left and right wings components will actually, since we have two of them inside the box, we will actually be flipping a coin to see which wings we're going to be using. So that means from the first set, we could be using the left wing. We could also be using the right wing from the second set. So it's going to kind of be a flip of a coin to see which wings we're actually going to be flying. And we could be flying a mixture of the set 1 and set 2 wings. So we definitely have to make sure we're making as consistent parts as possible for this year's mission. Additionally, we have an assembly time requirement, which has been really driving our ergonomic design, making sure things are easy to put together and take apart, or less so take apart, but easy to put together. And so our plane has to be assembled in under 5 minutes, which we're actually going to assemble the plane here for you today in a little while, just for the final part of the presentation. But it's definitely been a challenge to make sure things can go together easily within our time frame. So now we're going to play a video about our different sub-teams. So the video is going to have our different sub-team leads talking about what their team does and how they contribute to the plane. So.
All right, I'm JP. I'm the avionics propulsion lead.
I'm Aaron Greisen, and I'm the structures lead at Design Build Fly.
My name is Kenneth Versman. I'm the Chief Aerodynamics Lead.
I'm Tracy Gleish. I'm the payloads lead here at the University of Washington Design Build Fly Club.
My name is Alex Martin. I'm the manufacturing lead for Design Build Fly at the University of Washington.
Okay, the aerodynamics sub-team is responsible for determining what the plane looks like and ensuring it has the necessary performance requirements to complete this year's missions. The geometry team, which is more mostly focused on the overall geometry of the aircraft, ensuring what size the wings need to be, angle of incidence for control surfaces, what type of tail we have, versus the performance sub-team, which is primarily focused on calculating the numerical values of the plane, such as how long it can fly, what takeoff distance it can maintain, and ensuring it is both statically and dynamically stable. For this year's very unique challenge of having to place a PVC pipe directly on the end of the wingtip, we knew that initially being an incredibly complex aerodynamic challenge to deal with. So some of the key work we did was ensuring our vertical stabilizer had sufficient sizing and control authority that it could successfully offset the drag produced by the antenna in flight.
The structures team is responsible for designing all the structural parts. So they start from whiteboard drawings and then turn into CAD models, then turn into G-code models or DXF files for laser cutting or machining. After Aero kind of gives us a general configuration of the plane, we take those numbers on sizing for control surfaces, wing size, wing span, take those numbers and turn them into real parts that can actually be built.
Intentionally, we've kind of separated the manufacturing from the rest of the goings-on in the club. So it's kind of like its own thing that takes place during our winter quarter. So we go through the design phase in our first quarter during autumn, and then after we finish most of our design, we start actually building some of our aircraft. The reason we kind of separate it out is because it allows us to focus more on design at the beginning and kind of front load that so we can get all the heavy design work done when we do like turn in our design proposal and all that stuff. And then after that, we can start focusing on manufacturing as well and actually prepare for the competition. This year we decided to eliminate the manufacturing sub-team. So instead of having a group of dedicated members that focuses on manufacturing within the team, it's just me that does that. And the reason we did that was to allow members to have more of a sense of ownership over the parts they're creating. So like I mentioned earlier, in autumn, they're kind of focused on the design of their parts. And then as they get into winter, they get to come to the shop and build those parts as well. So it allows them to see the part through the entire design process, all the way from some simple sketches on paper to actually seeing it fly on the final aircraft.
I think one of the biggest things that we are doing this year to help us really win is make this plane out of composites. We haven't had a composite plane in a few years, and we have never really had a great composite plane, and I think this is the year that we're going to do it.
So our job basically divides by two parts. One part is propulsion and the other is avionics. In the propulsion stage, we design our propulsion system to fulfill our requirements. And in the avionics stage, we design our flight control system, our servo, and how to control our planes. So at the start of this school year, we'll start to talk with Aero about their performance, about about how we're gonna fulfill their requirements to make sure our plane has enough thrust to take off, have enough endurance for research mission. And in the later stage, like in the detailed design stage, we will talk to structures, make sure our parts will be implemented into our planes, like motor mounts and servo mounts. Thanks to our relation with T-Motors, we actually got a custom motor, and they ship us very quick, and that can fulfill our requirement for building all the other things because it's superior.
Payloads is anything that the plane is carrying, whether that be cargo or mission-specific pieces of equipment. This year, we have 3 sub-teams within the payloads team that are focusing on the 3 different unique missions of this competition. So we're going to be carrying a jamming antenna for one of our missions, and we have to design a mount to do that. We're going to be carrying a quote-unquote electronics package for mission 2, which requires not only creating the package, but also mounts and systems to hold it in place. And then also we have a ground competition, and that is essentially a wing loading test. So I want to say that like we went above and beyond like almost everything we did. Like this club has very high standards for what is considered good piece and good work. So I think every team really put in a lot of work to make this turn out great. But one of the ones that really stands out to me, just for the long and difficult process has been designing the shipping container for our plane. So this year we have a special competition rule that the plane has to fit within a very tight volume. So instead of just going with the easy cardboard or plywood box to achieve this goal, we decided to make a carbon fiber box, since that would maximize the volume we could get and just give us a strong box that stands out in competition. And each piece itself actually takes 3 hours to make. To manufacture in the composite shop. So it's just been a very long process, but in the end, I think worth it.
Okay. First of all, thank you to Ken Chen for producing that beautiful video. He's our media and marketing lead. He's always behind the scenes in the back there, and he just does some wonderful content. All right, so up next. Perfect. All right. So up next, we want you guys to hear from some of our members. One who is just gotten here, who is Alex Tamora. He is engineering undeclared. He's a freshman. He's been one of our best students at DBF here this year. He's really stood out. And then right after that, we're going to hear from a senior member as well. But for now, take the floor, Alex.
Good afternoon, ladies and gentlemen. My name is Alexander Tamora, and I'm here to speak for all the freshmen and first-year students at DBF. A sizable portion of the club, we make up an often unseen cohort of the overall organizational structure. And to say that the experience we gained here is valuable is an understatement. I am from Los Angeles and came to UW knowing virtually no one. My future was about as uncertain as my GPA after my first midterms. Yet, as part of the admits on the direct engineering path, I knew that my future as an engineer was certain. I have always dreamed of working in aerospace, where romantic visions of starships and satellites became not just what I dream of, but where I feel my future lies. First years were so important, but at the same time, I didn't know what I was going to do here while I was at this place. So, after a recommendation from a TA, I knew that the Design Build Fly Club was an opportunity for me to explore my aerospace interests. Unfortunately, the engineering launch, I didn't really get to know the people there that well. So, joining the clubs, doing a mediocre interview, and then getting through the process, told me that I had sort of low expectations. Going to our first meeting, before even our first general meeting, actually, I got to meet our first leads, and I got to really know them well. They're really kind, but unfortunately, kindness is not the same as experience. And they really told me that as a freshman, I had a lot to live up for. In fact, one of our leads, Pranav, he asked me a very good question that just totally stumped me. He asked me what an elastic modulus was. And my face was just completely blank. I had no idea what the heck he was talking about. But while getting used to his requirements was difficult, the fact is that I still tried to put in effort. Every time I'd look at DBF and I'd say, what can I do to help? What can I do to help not just learn and benefit my own life, but actually benefit the team as a whole? Doing layups, working eventually with the wing structures team taught me a lot. And I think the thing that has really benefited me the most is just, again, this experience, this sort of knowledge, the inherent knowledge that you get from learning about how engineering works, not just in the theoretical sense, but in an actual sense. Unfortunately, not everything is perfect, and I've definitely learned a lot through making mistakes. I think probably the worst one was when I made a wing spar as part of the wing structures team that was so bad, it was quote unquote the second worst layup Haley had ever seen. With the first example being an example where the wing spar completely disintegrated on releasing from the vacuum bag. However, again, these are learning opportunities, and I think a more apt description for a good learning opportunity was when I helped the wing structures design team develop what I call a detachable leading edge. This would extend the wing area of the wing. However, when talking to the aerodynamics sub-team, it turned out this was a misconception. This would actually end up lowering the aspect ratio of the wing, which would actually increase drag and ultimately make our wings less efficient. So this was not a mistake in terms of manufacturing or in terms of just not following directions. It was a mistake of understanding. And this is something that DBF is excellent at. Not just telling you how you got something wrong in like a literal sense. Oh, you're just a dumb person who doesn't know how to do their work. No, DBF is all about making sure that you correct things and have a deeper understanding of the things you do. But we bounced back. I took a marketing opportunity with the design notebook cover. And because I love art, doing art in my personal free time, this is something where I thought that I really excel at. So I applied for that. And of course, I also kept developing my manufacturing skills, working with the wing team again, making sure that the V2 wings were not just the same version as the V1 wings, but were slightly improved in a few tweaks. This definitely taught me a lot about what sort of structures kind of comes together and how this all fits as a whole. This is something that I definitely, again, would not have been able to get a good understanding of had I just taken a 210 statics. Of course, this is all leading up to the moment of truth, when I actually see these things in motion. Of course, this is the point of the unveiling ceremony, to sort of see the final fruit of our labor. But I like to think that before this has happened, I've also seen, again, the small benefits of my labor. The people I know, the people I've gotten to meet, the experience I've gained, and the opportunities that are now available to me now that I've put in this effort into this club. I am coming in off the opportunity of being the marketing lead for next year, and I anticipate that this job is going to definitely propel me even further than I already have. Again, because I've been able to work so well in this club and I've been able to make these great connections, this is something where, again, I'm going to benefit both my club and also myself. Of course, I think DBF is crucial for freshmen again. And I think DBF is an opportunity where freshmen can really get to know how the club works and how actual things in practice work. And again, schools like UW help inspire students to reach their potential. Ultimately, I think DBF is important to me because this is where I will really see where my life takes me. This is where I'm going to know how I actually will experience things in the future. And ultimately, DBF is where I learned that the elastic modulus is a substance resistance to being deformed elastically.
I so don't remember asking him that. Okay. Anyway, thank you so much, Alex. We have a running joke that we have way too many Alexes on our team. Next up, we have Alex. So, Alex Martin, he needs no introduction for all the DBF members. But if I were to say a few good words about Alex, he's one of the greatest guys I've met at DBF. Just a cool cat. He's always got his head on. He's never angry. He gets the job done. And for that reason, he needs to say a few good things about DBF. I'll give you the $5 later.
All right, hello everybody. As Pranav said, my name is Alex Cool Cat Martin, and greetings. I also go by Chief Sander, Guardian of the Shop, and my personal favorite, Alex number 1. 4 years ago, I began my career at UW, and about a few weeks later, I became a member of Design Build Fly at the University of Washington. As a freshman, I was eager to join an engineering club where I could enrich my college experience as much as possible, or at least that's what I should have been thinking. In reality, I joined DBF by accident. I can remember sitting in a dining hall with my good friend Tracy Gleish, who's in the audience today. And he was talking about how he was about to go to an introductory club meeting after eating. So I decided okay, maybe I'll go with him and see what happens. Little did I know, my college career was about to get a whole lot more exciting, and I was about to have a whole lot less free time. That first meeting was inspiring. The manufacturing lead at the time came dressed to kill in a full suit and tie, and in the first 10 minutes of the meeting, described everything our club does. Shout out to Ethan, who's also in the audience here today. I think I only remembered about 3 words of what he said, which was, we build airplanes. But what sunk in was his passion and excitement about the club. The faces around me in the audience reflected that same excitement, and I knew I was in the right place. For the next year, I worked on the nose cone of the aircraft. I started out working on CAD, but I quickly discovered that I most enjoyed the time I spent in the shop working with my teammates. After the fun I had in my first year, I couldn't stay away, and before I knew it, I was taking on a leadership role as the materials and manufacturing lead. As a lead, my experience in the club was elevated to a completely different level. I got to dive headfirst into the behind-the-scenes work that goes into running a club like this, and take on more responsibility as I helped lead the team to build our aircraft as efficiently as possible. The experience of these past 4 years has landed me internships and even my first job, but with all that technical stuff aside, my favorite part about this club has been the people. Some of my favorite memories of my time at UW are the late nights we spent in the shop laughing at our mistakes, the celebration after competition, after learning of our 9th place victory, and the insane conversations we had that usually end with, we should probably get back to work now. So to my teammates who have been in this club with me since day one, let's never forget the times we had here. And to the new members who are taking on leadership next year, get ready for one hell of a ride. To the rest of you, thank you for supporting our team. I wouldn't be here today without you. I probably can't put into words how much I will miss this team without crying, so I'm not going to try. But before we have to say goodbye, I'm proud to represent the team at one final competition, and I can't wait to show the world our work from this past year. Thank you.
Okay, thank you, Alex. 1. All right. So, you thought you heard enough speeches. We still have a few more. We're just trying to delay you as much as possible from getting to see the plane. And this one is actually going to be from me. And if I can figure out how a computer works. Okay, you are on that side. All right. So, yeah, it's me again. Thought I was just going to be an MC, but I've been tricked into speaking. That's completely false. I asked for this. And most people from DBF know that I'm not really one who sits down and writes speeches and, kind of plans things out. So I guess being ready 5 minutes before the event is as good a time as any. And that's what you probably saw me writing when I was sitting down right there. There's really no other way to put it than to say that DBF has really changed my life at university. The learnings I've had here are immeasurable, and they've shaped me into the engineer, manager, and the person I am today. Together, we've been through the highest of highs and the lowest of lows. There have been immense disappointments, like watching a plane go pretty much nose first into the ground after months of work. That really sucked. And even in our toughest moments, and boy, there have been really a few this year, there hasn't been a single time where we thought that we couldn't bounce back and make things better. That resiliency, that is a core feature of our team. And looking at the team we have for the future years, I don't think that's going to change. There have also been moments of pure satisfaction, like watching our plane touch down at competition for the final time and securing a top 10 victory. The absolute joy that we collectively felt in that moment was unparalleled. It was watching a culmination of 6 months aboard the struggle bus and literally bringing a team from 93rd place to 9th. And we were a part of that. At that moment, I understood what it was all about. Why building a plane that flies fast in circles just meant that much to us. Because it wasn't just that. It was an engineering endeavor. It was an exploration into the unknown for so many of us, into concepts and ideas that none of us had any knowledge of. And that was an amazing journey of learning, failing, iterating, and succeeding. There are a lot of people that I have to thank for this journey. So hold on as I go down a pretty long list. I want to start by thanking Ethan and Daniel. These two guys are the ones that pulled the club out of the ashes back in 2019. After crushing defeated competition, which Ethan used to fondly say, we don't talk about that. They took the bull by its horns and inspired a new generation of freshmen like me, like Kaylee, like most of the leadership team here today. We wouldn't be the organization we are today without these two rock stars. So thank you both for everything that you've done for us. Next in line comes Marymore RC Club. Their support to us has been invaluable, with Brian Kelly's expert advice guiding our pilots to keep the planes in the air. And another thank you to Shai, who's always pushed us in the right direction, gently, but definitely firmly, and has our best interests always at heart, even when he's telling me that you're not going to do it. We are going to do it. All right. A shout out to Mark Weber as well, who's provided us a lot of valuable insight and advice at flight tests and our preliminary design review. The next one's on the list, and a big one, is Boeing. Boeing has provided invaluable support technically and monetarily to us. Their funding has allowed us to progress to this beautiful composite aircraft that you're going to see today. R&D is a very expensive venture, and we can't thank them enough for the support they've given us. A special thank you to Steve and everyone at the UW Executive Focal Team for making this happen. And we can't forget to thank Doug Chappelle. Doug Chappelle is an engineer at Boeing who helped us with our preliminary design reviews. And Doug says the things to you that everyone else is too scared to say. Reading his feedback at 1 a.m. was definitely not good for my mental health, or my self-confidence for that matter. But it's made us critically think about our decisions and make better ones as informed engineers. Before I forget, I should also thank my personal financiers, who are my mom and dad. This is probably the biggest investment they've made, and I hope I don't end up like FTX to them. Yeah. And next, a big thank you to all our major sponsors, Blue Origin, Electro Impact, Janicki Industries, T-Motor, countless other ones that have supported us on this journey and make us able to develop the plane that we have in a very competitive package. And last but not least, my team. It makes me emotional to think that this is the last plane I'll be designing, building, flying, that's a mouthful, with all of you. There are many memories for me to take, especially the things that we've said to each other in the shop that should never see the light of day. You all are rock stars. And I mean that. I mean, come on, you built like an all carbon fiber plane. Like, who does that for fun? That's kind of a weird hobby to have. It just blows my mind that you have the ability to learn something completely alien to you and completely outdo yourselves while doing that. If there's a word of advice I can impart, it's something that my dad told me when he and my mom dropped me off at university. I'm only saying this because he's watching back home in India right now. No matter the successes or the failures, just remember your roots and the core values that you're with. In this case, it's the core values of the team, to educate and compete. When things get tough, as they often do when you're developing something fast and difficult, your values are what guide you in the right direction. So don't forget to educate and compete the next generation that comes on. With that, I thank you from the bottom of my heart for making this club what it is today. So thank you. Lastly, I didn't want to just be the only face up here that you remember from the lead team. So I wanted to put some names to faces of the old lead team to show you the people that made the magic happen. And we start with our chief engineer, Kaylee. We had our chief aerodynamicist up next, Kenneth. And supporting the aerodynamics team is the associate aerodynamics lead, Lily. I don't know if you can run this quick, but if he's back there, Ken, who is our media and marketing director, and the guy behind all the videos, Ken. Looks like he's going to be behind this video as well. Excuse me. And our technical director, Enoch. Our avionics and propulsion lead, Jake Lee. We're going to tire your hands out a little bit. We have Aaron Greason, who's our structures lead. Forgive me, that's Aaron Greason. I always get that wrong. All right, and Alex Martin, as you heard, our manufacturing lead. And we have Michael Henri Giordano, who's our business lead. We have Tracy Glage, who's our payloads lead. It's something with the E's and the I's. It's Gledge. So, and last but not least, the guy who actually makes it happen at competition. We have our pilot, Daniel Weaver. These are the guys who decided a social life isn't worth it and that building a plane is more fun. I'm with them on that. And we've had amazing moments together, and I won't forget them. Thank you all for making it what it is today. Thank you, guys. All right, and we have our last speaker for the day right after me. And I'm just gonna hand it off here to Kaylee, and I'll have you guys come off stage with me. Thank you.
All right. Well, thank you, Pranav, for giving that great speech. It's really, he's covered a lot of our thank yous. We are really grateful for the support everyone has given to our team these past 4 years, and it's been really special to be able to work with this whole team. But today I'm going to bring you a little bit back to where the club was at my freshman year and what our experiences were over the course of the last 4 years, leading up to what we've done this past year, and ultimately after me, you'll finally get to see the UW 23 sailfin. So starting off my freshman year, I came in with pretty much no experience. I was at Engineering Lunch, which is the event in the hub where you get to go and look at all the engineering clubs that are available. And I was like, I want to join a club so I can actually get some experience. And Design Build Fly was what really drew me to Design Build Fly was the fact that they didn't require any experience. And I was like, well, that sounds perfect for me. So I came into the first meeting and was really kind of just took, again, like Pranav said, Ethan gave an amazing speech of what it meant to be in the club and what we were going to be doing and learning, and just emphasized that we didn't need to have any experience going into it. And so I've taken the initiative across all my freshman year to make sure I was taking the time to learn and to grow as an engineer. And I think a lot of our current seniors really took on that educate and compete motto, because we came in as freshmen with very little experience, and the club has helped build us into the engineers we are today and going into industry or grad school after this. So that was really kind of what I developed my freshman year, was this love for the educate and compete motto, and going forward into sophomore and junior year, we really took that to heart as well. And during our sophomore year, we built a plane called the Dragonfly, which was really fun to build, and we learned a lot. We also made a lot of mistakes during that time, but because of that, we are where we are today, especially with composites. That was our really first full composite plane, and it was a little bit overweight. There were some other issues, but it was a pretty great plane to fly, to get to build and to get to learn through overall. And so after that, we went into junior year, where I was taking on the chief engineer position at that time. We had a lot of the current seniors again on the leadership team at that time, and we were really excited about getting back into the shop, because we had been a year and a half where there'd been a pandemic. We got to go back in person, and we were really excited about trying to build a plane that could do as good as possible. We'd seen our team come from so far from the past 3 years, and we really wanted to keep that going forward. And also, we had not been able to really recruit that many people during my sophomore year because of the pandemic, and we wanted to make sure we're continuing to build up the base of engineers we have in the club and continue that education process that we've talked so much about. And that kind of brings me into this year, where we also knew that we currently have 13 leadership members, and 9 of those members are actually graduating this year, which is kind of crazy to think about. So we're losing quite a few talented people, but we knew that we wanted our club to be able to carry what we've learned over the past 4 years and how we've grown into the next few years. So that's kind of been a big focus of us as well. We wanted to win competition. We wanted to make sure we're building up that next generation of engineers and engineers for this team, which is just been really fun, really special for me to be able to see this year. I know Alex was talking, there's so many other freshmen and sophomores in the crowd right now that have grown so much, and being able to see how much you're growing through the club and kind of compare it to how much I grew through the club as well is just really awesome to be able to see. And I know that this club can take people really far. It's taken me really far in my career. So I definitely couldn't have done it without the club, without the support of everyone around me and my family and my friends. And I just really, really appreciate everything there. And so with that, I do want to show you, just introduce you to the next leadership of this club. So they have done a really great job over the past couple years they've been a part of it. So I'm going to introduce the next chief engineer for the club. This person has been on the club for 2 years now, and he started off his freshman year as on the aerodynamics team. And he also helped out a lot during that year on manufacturing during winter and spring quarter. And this past year, he was on the structures team. So he led the wing structures for our aircraft. And I know that team has had a lot of challenges this year. We're doing a lot of really new and advanced techniques. And he's been a really big driver in getting those wings done. And he's a really great lead and great person. So it's my honor to introduce Giovanni Sykes, the future chief engineer of Design Build Fly.
Hello, everyone. I promise I'm the last person who's going to speak today. Finally get to see the plane. I am deeply honored to be able to stand here today and say that I am the next chief engineer of Design Build Fly at the University of Washington. I have a lot of high hopes and aspirations for this club, and I think we've gathered a great group of people who are going to take those aspirations and continue to soar higher. So without further ado, I want to introduce the 2023-2024 leadership team for Design Build Fly. Starting with our project manager, Andre Giordano. Our aerodynamics configurator, Lily Laplace. Our performance analyst, Ryan Fidelis. Our CAD and integration lead, Dean Bartolome. Our structures lead, Enoch Kwong. Our materials and test lead, Josiah Velagas. Our avionics and propulsion lead, Josh Lamelli. Our payloads lead, Catherine Gatormsen. Our manufacturing lead, Alex Kong. Our business lead, Alex Santana. Our marketing lead, Alex Tamara. And last but certainly not least, standing in the back, our chief pilot, Ken Chen. You can get one more round of applause for the entire leadership team.
All right, folks, we've kept you waiting long enough, and this is the moment you've all been waiting for. And I am proud to unveil with Kaylee and Giovanni right here, the UW 2023 sail fin. But wait. Wait, did you guys not get the plane? Oh, crap, wait, hold on, I'm gonna show that. Yeah, it's not that kind of unveiling.
Oopsies. Wrong light.
Can we get the lights on? That, ladies and gentlemen, is the UW 2023 sales pitch. Thank you so much. And now we can turn the house lights on and you all can come take a look for yourself. Thank you.
Ladies and gentlemen, that is the end of this presentation. I want to thank you guys for participating. Right next, we're going to move into Q&A sessions where people will be actively engaging with each other. But the presentation portion is officially over. We want to thank you guys for tuning in. We hope you enjoyed the show.
All right, folks, we'll make it a little easier for you. We'll set the plane down right here in the middle on a table so that everyone can see it. So if we could just clear this area right here, please. Thank you. All right, and can I get some of my leads up here to help with the table?
Anyway, yeah, we want to thank you guys for tuning in. We appreciate all of your support. We hope this has been an enjoyable show, and we have a sick-looking airplane. Please make sure to subscribe to us on YouTube. We have all of our video clips that are going to be published here. And follow us on our Instagram, DBF_UW, and we will be continuously posting our updates. I will be. I got you.
Yes.
All right, guys. See you guys later.
Hello, everybody. As you might know, I'm the business lead of the club, and it falls
yeah,
upon me
we're
to
fine.
shamelessly plug the fact
I can
that
help you.
our merchandise
I
stands
can
are also
post
now
the
open
table
again.
here.
They will be open until 4:45. Thank you very much.
Okay. No problem.
All right, please feel free to take pictures. Just make sure you don't touch the plane or knock it off the table by accident.
More than 100 pounds, yeah. Hey man, a little late to the party, but glad you made it. Also, Andre has my full frame f2.8 lens, so if you can get my camera from him and grab some snaps from that, that would be great too. Yep, it's that one. What size?
I want to look at small, either small or medium. Let me see how big this is.
Oh, you look great.
All right.
Our shirts look great on everybody.
Okay, thank you.
Yeah, I know, but a successful live stream and making sure all systems are smooth is good. Did you already pay, sir? I remember you were halfway through your purchase. I believe this was the one that you purchased. I know.
You should take a smaller medium.
Huh? Oh, small.
Did they say DBF backside? Same thing. Right. You want to, how much of those? You want to have travel. Without rings, but then, well, I mean,
All right, folks, the stream is officially ending. I want to thank you guys again for all tuning in, and keep your messages coming, and we'll be happy to answer to any questions. If you follow us on social media, you can send us a message there, and we hope to see you guys soon. Hope you enjoy the show. Goodbye.